Hello everybody. In the previous video, we explained how Chang'e-6 got into the orbit of the moon, and it's probably going around the moon at the halo orbit. Means it's a vertical orbit, not horizontal. Okay, and intention is to land on the South Pole, but it's not landing right away. The insertion was about the beginning of the far side new moon. New moon means the far side is day, so you can see the lights hitting the far side face of the moon, and it's keep going around the at the orbit that includes the South Pole for about 2 weeks. The daytime, what it's doing is, as you know, moon doesn't have this. It's not tilted like Earth. So if you are standing on the South Pole, the sunlight is at almost the horizon. If you are here, you get sunlight. So they about 2 weeks of daytime, you get the sun and charge up the solar battery, and it's go around the other side of the sun. Then two weeks of night, then you go sleep and come back and wake up. You repeat this process, and China did that already many times. The problem is, what is tricky is South Pole. The sunlight coming at almost horizon. So as you know, Earth's South Pole, during summer you get sunlight every day. There's no night, right? But it's tilted other way around. Winter, you get no daytime. It's always dark. And the moon, we have a situation that this is not tilted at all. So South Pole means you have very low angle sunlight, and when you land on the crater, like a crater, okay, the sunlight is completely shut off. So you landed on the crater. The intention is to land on the one of the crater. You see there are many craters. I don't know which one China is trying to do. I think that they try to figure out next 2 weeks which one you get the sunlight from this direction, because this is the far side, and they pick the crater that get sunlight during the day on the far side. Okay, so you don't wanna end up with landing here, then immediately you don't get any sunlight, then the battery die, so you cannot continue. It's very tricky, this kind of things. So you have to do very careful. You cannot just go there and humorously, oh yeah, we're gonna land. You cannot just land at any location. You have to pick the one. So probably China is observing right now. This is the far side. It's day, and the light is hitting. How much light is hitting? They are observing probably the light penetrating into this area, South Pole, and that takes 2 weeks. Then it's going to be full moon eventually. Next 2 weeks, you don't wanna land there, because when it's night, you land it, then battery die right away. So you have to wait 1 month, whole month, the next new moon. So insertion was during a new moon, and observe the light penetration and determine where to land. Then they adjust the coordinate and make a very accurate landing on the spot where you wanna be. So within a crater, intention is to land within a crater. This crater not too high, so still sunlight's coming in and shine this area. Okay, and that's what Chang'e-6 is doing. So it takes one full day, which is about 1 month, on the moon. Just observe and map the light exposed area and determine where to land it. And next day, which is new moon, going to land on the exact spot. If you land here, you may not get enough light to collect for the battery. So this is a complication. This kind of things you cannot just say, hey, yeah, just land anywhere. It has to be very carefully planned. Okay, so Chang'e-6 probably is not gonna land until next new moon. Right now, new moon is over, and gradually it's become full moon. Full moon means it's night on the far side, and you're not gonna land on the night. So that's a tricky part in the South Pole. You don't get the light, immediately die out, and it could be that because of that this Indian moon rover landed and they immediately die, and no communication and no chance. The Japanese one landed upside down, and they reported they collect the light and the battery revived, so they can communicate. But it's the solar cell is attached to the back of the lander, and it's standing upside down, and that may be a good thing. So some part of the solar cell exposed by the light, and that's why they recover some battery power, so they can at least do communication. But beyond that, there's no report from Japanese side. There's nothing, no technical details at all. I think it's a battery is the issue. So this is not trivial problem. You have to map for whole day, 2 weeks, and pick the location where you get the sunlight. Then you land at the exact spot so that you get the sunlight. So sunlight will be much weaker because it's the angle. So the way they design solar cell is for this one is like a vertical and sticking out from the ground. Okay, so that's what is going on. There are a lot of details, technical details you have to clear in order to make a successful landing and a successful exploration of the South Pole. Okay, that's all for today, and if you like, please subscribe and click likes. We'll see you next video.